Okay, let's think a little bit more about the setup of a hypothesis test. So take a second to read this. A group of local businessmen is thinking about developing land in a shopping mall. To evaluate the desirability of the location, they count the number of shoppers who visit the neighboring shopping center each day. A random sample of 25 days reveal a daily average of 107 shoppers with a standard deviation of 23 shoppers. Okay, so right away we have the sample size, which is 25 days, and the sample average is collected. So on each day, there's 107 shoppers for the neighboring mall and a standard deviation of 23. Okay. Now, the businessman will develop the land if the average number of shoppers per day is more than 100. So, there's actually two different hypothesis tests that we could construct. So first, we can say this one. We can say that the mu is greater than or equal to 100. So whereas the true average number of shopper is more than 100, then that way the alternative will be mu is less than 100. Or we can have this hypothesis test that the mu is less than or equal to 100, and the alternative is greater than 100. Now, both of these are actually correct. Both of these are completely valid hypothesis tests. So which one would you use? Well, actually, that depends on what you want to support. Right. So here's the thing about hypothesis tests. Right. It does have limitations, and we talked about this last handout that we can either reject or accept the null hypothesis, but we can never support the null hypothesis. Right. So if you want to support a claim, then you must set it as the alternative. So then we must make some assumption about what these businessmen really want. Right? If their goal is to convince the investors, right, that the average number of shoppers is more than 100, then this will be the one that they would like to choose. Right? However, if their goal is to really rigorously test test the population, and let's say that they don't want this investment to happen, then you would choose this one. But judging from the wording here is and if we can make an assumption about the goal of these of the developers, then we will use this one because they would like to support this claim. Right? Because they would like to make the investment and they would like to support that the fact that the average number of shoppers per day is more than 100. And the goal then will be to collect enough evidence to reject the null hypothesis. Okay. All right. So let's go ahead and finish this test. Finish this hypothesis test. All right. So I'm going to write it down here again. So here's the hypothesis that we will like to conduct. Okay, so again, we would like to reject the null hypothesis so that we may support the alternative hypothesis. Okay, now here our sample size is 25, and so our sample size is 25. So we must assume normal distribution. So meaning we must assume that the original population, meaning the average, meaning the daily shoppers, follow a normal distribution in order for us to proceed. Okay. All right. Now let's go ahead. And the first step you always want to do is calculate the test statistic. I'm going to go ahead and plug it in here. And that comes out to 0.522. Okay. Second, I want to find the critical value which to compare this test statistic with. Okay. Always go ahead and sketch. Okay. That way you won't make a mistake on which side your critical value goes. Here, my null hypothesis is a less than or equal to. So I will only reject if I get a really large number. Therefore, my critical value is over here. It is a one-tailed test. So my alpha is goes 0.10 all over here. Now, we have to decide which one do I use. Since I don't have sigma, or what I would say which one is, do I use the z distribution or the t distribution? Since I do not have sigma, and I'm using sample standard deviation to approximate, I'm going to need to use this. All right. Okay, so I'm going to go ahead and calculate the degree of freedom as well. Degree of freedom is n minus 1, so that will be 24. So I'm going to go ahead and use the app to go ahead and find out what that is. I go to t distribution, put in my degree of freedom 24, and then I put in 0.10. Now I want, yes, I want it on to the right. There we go, 1.31. Go ahead, 1.318. All right, so my zero, remember my zero is there. Critical value equals 1.3318. Where does my test statistic fall? My test statistic falls to the right, because my test statistic is 1.522, falls to the right here. So I can write that, well, my test statistic, it is greater than my critical value. Therefore, we reject the null. And now we can say, once we reject the null, we can say, so we can create a statement such as this. There is enough evidence, right, to support the claim that average number of shopper running out of room, shopper is greater than 100. Okay, now we can, because we reject the null hypothesis, we can support the claim, but we can only support the claim if it's in the alternative hypothesis.